Okay, what if I told you that the very laws of physics that built our entire modern world are, well, about to get a major update? For decades, we've been on this incredible journey, making our technology smaller, faster, and smarter. But we've just hit a wall. A really, really weird wall. And what's on the other side is a whole new way of thinking about computers. For over half a century, technology followed this amazing, almost magical rule. Computers get twice as powerful about every 2 years. It's this relentless doubling that gave us, well, everything. The internet, the smartphone in your pocket. It literally defined the world we live in. But that era, that predictable, reliable march of progress, it's ending. And it's not because we ran out of clever ideas. Nope. It's ending because we have run headfirst into a fundamental barrier, a wall made of physics itself. Think about it. We went from the first clunky computer chips in the 60s to the PC revolution in the 80s to the mobile supercomputers we all carry around today. And every single leap was powered by one simple idea: make the parts inside smaller. But now we've made them so small we've hit the atomic wall. So what exactly is this wall? Well, it's the point where our technology becomes so ridiculously tiny that the bizarre, almost magical rules of quantum physics start to, tear up our instruction manual and just break our machines. Let me introduce you to the unsung hero of the digital age, the transistor. The easiest way to think about it is as a microscopic light switch. It can be off or it can be on. That's it. Billions of these tiny little switches, all working together, are what make your computer actually compute. The whole system is really simple and kind of brilliant. You've got this tiny little gate controlling a path for electrons. When the gate is closed, no electrons get through. That's your 0. When you open the gate, electrons flow. That's your 1. On, off, 0, 1. For 60 years, this solid, reliable logic has been the foundation for everything. Here's the problem, though. We've pushed this simple idea to an insane extreme. A modern transistor is about 14 nanometers wide. I mean, that is just absurdly small. We're talking 500 times smaller than one of your red blood cells. And when you start operating at that scale, you're not just in a small space, you're playing in a whole different physical reality. And in this new, bizarre reality, a strange effect called quantum tunneling takes over. Get this. An electron can just teleport straight through a solid blocked gate. It vanishes from one side and just pops up on the other, like a ghost walking through a wall. And all of a sudden, your perfect off switch isn't really off anymore. Your zeros start leaking, and the basic logic of your computer just starts to fall apart. So the very physics that we use to build our world is now working against us. What do? Well, this is where things get really, really clever. Some brilliant people started asking a radical question. What if we stop fighting all this quantum weirdness and start building with it instead? As one physicist put it, in the quantum realm, physics works quite differently, and traditional computers just stop making sense. The old rulebook, you can pretty much just throw it out the window. And that question sparks this massive idea. Instead of treating these quantum effects like a bug, what if they're actually the ultimate feature? What if we could build a totally new kind of computer that runs on these strange, incredibly powerful new rules? This new kind of machine is built on two concepts that feel like superpowers because they just don't exist in our everyday world. They're called superposition and entanglement. So here's the big shift. A normal computer bit is like that light switch we talked about. It is either off, a 0, or it is on, a 1. It's definite. But a quantum bit, or a qubit, it's more like a spinning coin. While that coin is spinning, it's not heads or tails. It's both heads and tails at the exact same time. This mind-bending state of being multiple things at once is called superposition. And that one little difference, it changes everything. Because a single qubit can hold both a 0 and a 1, a small number of them can process a staggering number of possibilities all at once. Get this, just 20 qubits can work on over 1 million values at the same time. This isn't just a little bit faster, it's a completely new way of looking at a problem. The second superpower is even weirder, if you can believe it. It's called entanglement. Imagine you have 2 of those spinning coins, but they're magically linked. The instant you stop one and see that it's heads, you know with 100% certainty that its partner is tails, even if that partner is on the other side of the galaxy. Einstein called this spooky action at a distance, and it lets these qubits work together in incredibly powerful and coordinated ways. All right, So we have these new mind-bending tools. What can we actually do with them? What are the real-world problems they could solve that our best supercomputers today can only dream of tackling?
Well, the potential is just staggering. We're talking about the ability to design new, life-saving drugs by perfectly simulating how molecules behave, or discovering brand new materials to build things like hyper-efficient batteries, or even creating artificial intelligence that can take on huge challenges like climate change.
Let's take something simple, like searching a giant database. A classical computer has to check every single item one by one. It's slow. But a quantum computer, using superposition, can basically look at everything all at once. For a huge amount of data, that's the difference between a task taking centuries and taking just a few minutes.
Now, this incredible power, it also has a really disruptive side. All the encryption that protects our banking, our private messages, our entire digital world, it's all based on math problems that are just too hard for normal computers to solve. But for powerful quantum computer, it could break that encryption in a breeze.
But maybe the coolest, most elegant application is this. See, simulating the quantum world on a classical computer is incredibly difficult. So, what better tool to model quantum physics than a computer that's literally built out of quantum physics? This could be the key to finally understanding diseases like Alzheimer's by letting us perfectly model how proteins fold inside the human brain. The thing is, we're standing at the very, very beginning of this new computational age. And if we're being honest, nobody really knows where it's all going to lead. The map is completely blank right now. Is a quantum computer going to sit on your desk one day? Probably not. Or will they stay as these giant, specialized machines tucked away in labs to work on humanity's biggest challenges? The most exciting part is, we just don't know yet. The journey is just getting started. And that really leads to the final big question. We created this amazing new technology to overcome a physical limit we ran into. But the real question is, what unimagined problems will it solve? What new mysteries of the universe will quantum computers let us ask for the very first time?